Hi, I'm Alex Lee, and I'm currently a senior at the Webb Schools in Claremont, California.
And my name is Melissa Lee, and I'm a junior at the Webb Schools in Claremont, California.
For a little background, falls are actually one of the leading causes of injury and deaths in older Americans. And two commonly used tests that are standardized to predict for fall risk are the 30-second chair stand test and the 5 times sit to stand test. However, the problem with these manual measurements is that these tests are labor intensive and require the observer to manually use a stopwatch, provides limited data collection, and there's observer intervariability. And so our Internet of Things chair was our solution. It wirelessly and automatically measures the sit and stands. When we designed it, we had a few goals in mind. We wanted to make it low cost, make sure no device was attached to the person performing the test. We wanted to perform automatic measurements while providing expanded data collection and accurate results, giving the doctor additional information to interpret and to aid their patients. To assemble these components, mount a sensor under a corresponding leg of the chair. Next, connect each sensor to an HX711, which takes the strain gauge's analog signal, amplifies it, and turns it into a digital signal before connecting those four HX711 to our ESP32. It's essentially the brains of our device. It's a CPU with Wi-Fi connectivity.
Our firmware was developed in Arduino, our data collection server was coded in Python and ported over to PHP, and our browser sends commands to the ESP32 via an MQTT broker. The data collected by the ESP32 is then sent via HTTP post to a server, which then sends data to a browser for graphing. We got IRB approval and tested our IoT chair in a clinic. 100 participants completed the 30-second chair stand test, and 98 completed the 5 times sit stand test. Using statistical analysis between the IoT chair and the observer method, we saw no significant difference, meaning our IoT chair is just as accurate as a traditional method. Additionally, here is a graph showing what an observer would see after the test is completed. And here's a video demonstration.
So we'll be doing a live demonstration with my sister. So we'll be doing a 10-second test, and she'll be user number 808. So we'll have my sister sit on the chair, and when I press start on the app, she'll sit sitting and standing, and that sit and stand data will be automatically recorded by our app. It's stored, and then it's displayed on our database. And so if we go over to our database here, if we go to user number 808, you can see right here, this is our new trial. You can see each sit and stand repetition that's been performed by my sister. And so in this 10-second span, she successfully completed 3 trials.
Additionally, here's a graph provided by our IoT chair that is showing a patient's leg strength. Lastly, our IoT chair provides additional benefits as it's automatic, is easy to use, is low cost, and has expanded data collection. Thank you.